Good evening, my name is Colin Murphy. I'm the Chief Executive of Firebird Solutions. I want to thank you all for giving up your time to come to meet us today. I want to thank Steve and Nicola for organising this evening and saying hello to them and letting them travel up from Christ Church. When Lewis and Smith went looking for a diesel boiler in about 20 years ago, they were looking for a product that would be reliable, robust, clean burning, and that would be good value for money. They were also looking for a partner that would be able to listen to them, would react, and that they could trust. In the nearly 20 years since, the teams in both businesses have worked very hard to deliver on those early promises. The Firebird motto is on row is far, small writing up there, close. That means the best choice, and certainly in central heating, New Zealand, we have made the best choice. They're a marvellous company to do business with. Our industry provides warmth and comfort to people all over the world. Hydronic or water-based systems is the norm in Europe and improves the quality of people's lives. A bit about ourselves. Our factory is based in the village of Ballymakeera in Cork, in Ireland, about 40 minutes from the sea. It's one of the few areas in Ireland, shaded dark green, where the Irish language is still spoken in people's homes. It's an enterprising village. There are about 12 locally owned businesses and factories in the village producing a variety of products from robotics for bottling plants. We produce the foil that people put cabinets out through coffins, and there's a variety of food and beverage companies. This is a photograph of our complex where we've built 3 factories over the past 40 years. We employ 100 people in our heating division, and we established a sister company 20 years ago called Fireblock that makes fire retardant metal doors. The very first product we made is a central heating back boiler. We're best known for our oil-fired or diesel-fired central heating boilers. Our sales are roughly 1/3 to Ireland, 1/3 to the UK, and 1/3 to the rest of the world. New Zealand was our very first market outside of our home markets of the UK and Ireland, and it's very special to us. We get a great buzz for every order we get from Christchurch. Both companies speak very frankly and regularly. Both companies are very focused on the customer, and I think that's why we work so well together, trust each other so much. Our focus as a business has always been on the installer. To deliver on that focus, we need to supply products that are reliable and robust, that they're easy to install, and that they're easy to maintain. And that's how we've been measuring ourselves from the start. As a company, we focus on 3 items when we're making investment decisions. We invest heavily in staff training and research and development because we need to stay at the leading edge of our industry. And we also invest very heavily in automation. The reason we invest in automation is we must keep the cost of our own production low, because that will give us the ability to buy in the very best of materials and components for our products. Like every business, we have an organisation structure with finance and operations and engineering. In order to keep our business customer focused, we try to get our people to meet with customers at least once a year, no matter what department they're in. There's a line missing off that, which is our suppliers. We have some very important suppliers that work really closely with us, and Elco is a key supplier of ours. This is what we want our brand to mean, and we work that the industry looks on us this way. We can't judge ourselves, but we hope that this is what the industry sees and thinks of when they hear Firebird, that our products are of high quality, highly reliable, and that we give great training and after-sales partnership, and that we're a good company to do business with, no matter where on the chain between us and the household or the business is operating. Service, pre and after sale service is very important in our industry. In our 3 depots in Ireland, the north of Ireland and the UK, we've built training schools about 15 years ago, and we focus on 3 things: upskilling for our new technology, refresher training for commissioning and servicing, or introduction for new guys to the industry, and we introduce our key suppliers. So we're doing that today. We're touching on all these 3 areas here today. Backup support before and after the installation is really key. We know installers, if they're at a site and there's come across something that's puzzling them, they need an answer very quickly. They don't need to get on to the receptionist and be told we'll be back to you tomorrow. They need the answer straight away. And we know that in Christchurch there's a great team of engineers who provide that service to the very cost ranges into heating New Zealand products. Before I go on to the next slide, Mario's touched on it, and Stuart will be talking about their carbon dioxide. You know, if you're in the heating industry as an engineer and you're going to make a living out of it, it's important that you have a properly calibrated flue gas analyzer. It's as important to you as a stethoscope is to a doctor. You absolutely need it if this is where you're going to be making your living. Just a flavour of the other products that we do, so you'll understand our business better. The diesel boilers we supply here in New Zealand, very important market to us. We make solid fuel cookers. This is what we started. We make solid fuel cookers. We started off as a solid fuel boiler company, making solid fuel boilers to heat radiators, and we still make stoves. And we assemble kits for air source heat pumps and solar thermal systems. In terms of where we are research and development, the most recent product we developed is your New Zealand boiler. Before that it was the upgrading our combustion to blue flame low NOx combustion. In terms of where's our industry going in the future, certainly the diesel fired or oil fired industry. Where we're going next is looking at decarbonising the fuel. So our trade association, with Firebird leading, is looking at reducing the fossil fuel content of our fuel in a controlled, methodical way, working with government and regulators. So we've an interim target of 30% by 2030 and more ambitious targets for further on. Just to give you an idea of where we've travelled in terms of efficiency, I joined Firebird in 1998. The first EU efficiency directive had just come in, and at that stage there were boilers on the market with fuel efficiency of 70%, and the flue gases or exhausts were leaving the chimneys at 230 degrees Celsius, which obviously was a waste of energy. By the by 1999, we had reached the maximum efficiency of a standard efficiency boiler of 86%, and shortly afterwards we introduced the condensing boiler, the Enviromax brand, which has an efficiency of roughly 95%. One of our products is the world's most efficient central heating oil boilers. It's top of the database maintained by the UK government. Just to put that in perspective, in terms of say our 95% or 95% efficiency boiler, the best diesel cars you get are only getting efficiency of about 41%. So diesel fired central heating is a really good use of fuel. And we moved on to blue flame burners, low NOx burners. They're now standard right across our range, starting 18 months ago. That's enough about us. I'm going to talk about New Zealand now for a bit. We were invited by our partners here to come to New Zealand in August 2017. We wanted to talk about the boiler and how it was being used in New Zealand. In the months before we came, the management in Christchurch talked to the installers and asked them, if you could make a change in the boiler or if you could design your own boiler, what kind of features would you like? So we spent a day and a half with the team in Christchurch, one very long day, one small half day, and then we went on the road with Lewis Smith to meet as many installers and visit as many construction sites and existing dwellings as we possibly could, so Stuart and I could get a real good picture of what you guys are dealing with every day. So I've brought these two pictures. I hope you can see them at the back. Here we've got a photograph from our UK brochure, just to show a typical UK diesel boiler. There's a boiler there. On the left, we've got probably a dishwasher, and on the right, you've got cups and saucers, and the lovely worktop running the full length of that. So this is the market we were producing our boilers for all along. The installer, the service engineer, has to have access to everything through the front door. On the right, we have a picture of Stuart, who some of you have met, and that's about 20 miles north of Queenstown, and that is a plant room where you can see the top is off the boiler and there is clear access to both sides. So we were told, and we saw for ourselves, we never ever put a diesel boiler into a kitchen in New Zealand, and there's always full access all around it. This opened our eyes because once we understood this, we could see how we could very quickly answer all the issues that the installers had brought up before we visited and as we visited. So we had a long trip back to Cork. We had 5 away in Auckland, 6 in Singapore, and another 5 in Heathrow. So at the stops, we sat down, it was quiet, went through all our photographs, all our notes, and came up with a list of 29 action points that we needed to address. So these main things that we learned, I've talked about the freestanding and the worktop. Essentially, New Zealand wanted our boiler to look better. In our mind, an indoor boiler is only looked at from the very front. I'm looking at the boiler here from the side, as your customers were, and from the top. So we wanted to look the part from all angles. We discovered New Zealanders are very house proud, and that New Zealand tradesmen are professional. The standard of finish in New Zealand is far superior to what we'd see regularly in the UK and Ireland, where houses tend to be built in estates of 100 houses all the same, and the developer just wants you to get in and out quickly. Here, every house is individual, and the owner cares about the finish and the quality finish. So the tradesmen care about the quality finish as well. We wanted easier access to the system components. The roller flue we were supplying you was designed for a UK and Irish wall, external walls which are very, very wide. We didn't know your walls were so narrow, so we were making your life very awkward by giving you a flue suitable for a wall built on the other side of the world. So we addressed that. We discussed refresher training and commissioning, servicing and flues, and we're discussing that here now today, and it's part of the Central Heating New Zealand training as well. And finally, August 27, we were 13 months away from the Blue Flame roofs coming into Europe. We were at the very final stages of our testing with EDCO in England and Ireland on our Blue Flame technology. So what we agreed as we were talking with the guys in Christchurch was we'd finish out our testing, get it on the market, and they said yes, of course, with all the benefits to the environment and to the boiler of this clean burn technology, that we should look to bring that to New Zealand. So that's what's not written here is the great reception we got from the homeowners in New Zealand. They love the comfort and the quietness of their products, the reliability, and especially the instant heat you get from a diesel boiler, where you get that big rush of energy right from the off. The installers enjoyed working on the products and had a great time for both ourselves and Central Heating New Zealand. We have lots of positive. So the results of the 18 months work we've done since is a modern Firebird blue flame diesel boiler developed specifically for yourselves by Firebird, Central Heating New Zealand and Elco all working together. It surpasses EU efficiency and NOx emissions, and it meets our core values. How we got there? When Stuart and I got back to Ireland, we called in the management team and the key engineers, and we said, look, we make world-class boiler and we have our core values, but we can do a lot better for the installers in New Zealand and the homeowners in New Zealand know that we've seen what is required. So we assembled a team of 8. We put Stuart in charge of it, and so that included our combustion engineers, boiler engineers, computer-aided design guys to work on the layout of the components, and our procurement guys to pull things together, and key suppliers to make the special New Zealand composite panels for the boiler. So originally I was finished here, but as we said, there are some people here who are very familiar with central heating and diesel boilers, and others who are new to the industry. So as the lay person here, the only non-engineer who's talking to you tonight, it fell to me to go through briefly a layman's version of the terminology that we're using. So I'll start with NOx. Our atmosphere is made up of nitrogen and oxygen, roughly 80-20, and a few other gases. And there are 2 gases we need to live. The problem arises at very, very high temperatures. The nitrogen and oxygen elements can combine to form different compounds. So NO2 is the most common one, but you get other nitrogen-oxygen compounds. So that's where it's nitrogen, oxygen, and X for the type of the compound that's made. There are a few issues with NOx. One is that it's one of many global warming gases, so we need to reduce it. The second issue with it is that it causes respiratory problems for people with respiratory illnesses. So people with bronchitis and asthma living in built-up areas, a build-up of NOx is bad because it can lead to a smog, and that's a bad thing for people living in built-up areas. So that's been regulated out. So that's what NOx is. Blue flame. If you're combusting on a yellow flame and you can engineer it so that the colour of the flame turns blue, then your level of NOx emissions will automatically drop. Blue flame burns at a more even temperature throughout. The yellow flame has more variability in it. So just what you need to do is go from yellow to blue, and Mario has explained about that. And there's a term then that we use as well, which is clean burn. Blue flame combustion will have less unburnt carbons in the exhaust than yellow flame, and we can see unburnt carbons as soot particles, and we don't want soot in a boiler because it acts as an insulator. So if you get a little bit of soot building up every day you use the boiler after it's been installed or after it's been serviced, then you would put a slight coating on the metal of the heat exchanger, and that will act then as an insulator. So when you come back 12 months later to service the boiler, the level of efficiency will have dropped slightly. By having a clean boiler, as you know too, it's easier to service and it's more reliable. So thank you very much for your time, and like I said, we're all here afterwards. We're staying in the hotel tonight. We're in no rush, so if you have any questions, come and talk to us afterwards. Thank you.
Welcome tonight. My name is Stuart McQuilly. I'm the Principal Engineer for Firebird Heating Solutions. I'm very lucky. I have a team of engineers, dedicated engineers, that work with me for product development. When we came back from New Zealand a couple of years ago, we had a list, 29 points, that I gave the engineers to work on, and the result is this unit of today. Now, what I'm going to do, I'm not going to go through every part of the 29 parts that we went through, but I'll go through the principal parts for that boiler. So, I know it's been a long day for you. We're going to go through a few slides. Hopefully it's not too warm and a lot of you don't start going to sleep. But we'll sit through these, and then afterwards we can all meet downstairs. We can have a beer, have something to eat, and then you can ask me any questions you wish. Okay, one of the areas that I'm responsible for is the quality and design of Firebird products. Now, we have to make sure those are manufactured to the highest standards possible. We come in under the umbrella of the European Union, where we manufacture our goods. So I'm driven by a host of directives and a host of other things, and hopefully we make sure that those products are up to speed, up to standard, and the best quality possible before we sell them on or we supply them on to people like yourselves. All our products are designed by CAD operators. They're highly technical guys, they put a lot of effort into this, and as you can see by the build quality, I think you'll agree with it. And as Colin said previously in his presentation, we try to use the most manufactured to the most premium products that we can. So in a minute, what I'll do is I'll go through the construction. I hope you guys at the back can see the construction of our boiler, and to prove that to you. Okay, engineering department. I have a mission statement like every other company, and that is to provide innovative heated solutions at cost-effective prices. All right, that just says it all. I'm given a task by the Firebird management to keep costs down and make it cost-effective, but I also have to make sure that I give the best product available. Now, the challenge, a couple of years ago, started off as a 2-year research and development program, was to develop a highly efficient unit for your market, maintain our outstanding reliability and performance, and allow for installation and maintenance. And I think we've started that already, because a lot of you guys would have seen tonight, we've got this removable panel on the side. Quick acting screws, just one flip, 90 degrees, take the panel off, and inside, I hope you guys can see it. Do you want to put the light on a minute?
Yes. I'll probably get this one wrong. Yes.
Hopefully the lights will come on. Yep. And just about see in there, we've kept all the pipe work to the side of the boiler, which allows you for easy maintenance and it also easy installation. You can see that we've got the pump on the return as well, and I'll go through that in a second. But if we look at the pipe work, we can get access from the side, we can get access from the back, because there's a cut-out panel at the back, but also if you're coming up from the deck, you've got a cut-out in the base of the boiler as well. So you've got all those options to actually be able to install it to the design that you want. If we look at the pump, we've gone to a bit of a smart kit here. The pump itself is glandless. You may be familiar with the Grundfos pump, where the impeller was actually part of the stator. In this particular pump, it's separate. There's magnets rotating inside the stator, and the impeller is driven by those magnets. And what that means is if there's any debris that gets in the system that's flying around the radiators or the underfloor and it's not taken out, then it doesn't get into the stator and it doesn't write the pump off. If you do get debris in the pump, this thing starts to shake itself. Now, it's not broken, and it hasn't got into a fit, but it's intelligent. It's got a PCB in it that allows the pump to figure out that it can't actually move the impeller. So what it will do is it will shake, and you'll see the lights on the top will actually blink. Now, this pump has got two modes of operation. It's got a constant flow, or it's got a variable speed. So if you put it on underfloor, you can imagine when your heads are coming down, the flow restrictor is becoming more, so this pump will counteract that and will reduce its speed accordingly. So that's one of the features that we put in. Another one that I like, in fact I like it so much, we put it in our European boilers, is a removable air vent. You can undo this. I would recommend that you reduce the pressure first, but there is a non-return valve in the top of the boiler where you can take this air vent out. This air vent, you can easily unscrew. You can take the little float out, give it a wash under the tap, get rid of any debris. It's what we actually find. It's a pressurised boiler. We set the pressure to about 1.5 bar under normal circumstances. If the air vent starts to leak through its little air cap, you start to lose pressure, and that causes us a lot of issues. Customers are unhappy because when this gets down to 0.5 of a bar, the low pressure switch that's fitted in the boiler will actually cause the boiler to cut out. It's a safety device. 9 times out of 10, the leak can be traced to the air vent. So we've changed the air vent. We've made it so that you can maintain it and pop it back into the boiler itself. We've used a lot more composites. And we've got a flip down panel. You've got your normal control there because it's in my eyes, if you hide something away, it stops people fiddling. So you drop the panel down and they've got access to the thermostat for control for the boiler. You've also got a series of lights, mains, to tell you that there's mains onto the boiler. Burner light, because if there's a defect with the burner, we want to know if there is electricity or power going to the burner. Now, this is more relevant for your outdoor boiler because if you see tonight, we've got a plastic drop-down cover. That allows the guys at Central Heat New Zealand to start on the road of diagnosing what the issue is. If the customer, and we don't want the customer to take the door off, the customer can tell them what lights are actually lit, and those guys on the end of the phone know where to start. So it's a good diagnostic tool. Who's familiar with the older type boilers that we used to produce? And the graphite sheet. Thanks a lot. We have now designed it so you have one insulated board instead. Now this is retrofittable. If you take the combustion door off, there's no more graphite sheet. No graphite sheet that you can cut your hands on if it splits, and it doesn't have to be changed after 2 or 3 years. This board should last considerably a lot longer than that. Now that board, as I said, is retrofittable, so you can take the old board out of the boilers that you have in service at the moment, and you can actually get that as a replacement. Let's talk about the track. Previously, our boilers were fitted with a plastic trap. The plastic trap fitted on the bottom there, but the problem was that we were finding if there was a few hand-fisted guys out there, they'd strip the threads on the plastic. So to counteract that, this is not just for your market, we're doing this on all our European boiler models now. We've gone to a 316 stainless steel trap. The reason being is you can't strip that, and that will last for a long time. Remember, when you're fitting the trap, the water that's produced and goes into this trap is slightly acidic. It's got a pH of about 4, which means if you let it drop on the concrete, it will start to eat away the concrete. It will also eat away copper and mild steel. So remember, when you're fitting your trap system, the water in here has to be discharged to a safe area. Now that could be to a drain, or it could be to a soakaway. We supply a plastic pipe that goes on here, that leads through the side of the boiler. From then on, change it to plastic and lead it to drain. And then you won't have any problems. So, carrying on with the slides. There was a couple of things. The 6 primary objectives for this boiler was modern clean lines. I think you would agree that that's achieved. We've also put in magnets in the top of the boiler and in the door of the boiler, and they're quick acting magnets, so you can just pull it off. There's no more pulling the door off and having loads of trouble with that. Plug and play technology, the guys that have seen the demonstration on the tables tonight, I've been through that, Mario's been through that, where if you have to change a component on the burner, it's one simple operation. You don't have to get involved in all the wiring. Just use your 4mm Allen key and pull the component off and replace the component. has to be affordable, definitely reliable, and it has to be efficient. And of course, one of the good things about using the burner that we have is it's got low NOx. Now, how many of you, I don't know how the principle of our boiler works? Well, I'm just going to go through that situation now, because I'm looking at the efficiency side. I'm talking about a standard condensing boiler that is highly efficient. If we strip everything out of this boiler, we're left with that over there. And I hope that most of you can see it. Our boiler is made out of two principal chambers. Primary chamber 1, made of mild steel, which contains the baffles, and chamber 2, which is stainless steel. It's made out of 316 stainless steel. The reason is I'll go through in a minute. Now, if you can imagine, your burner is firing into chamber 1. Chamber 1 has now got hot combustion gases, and they've got to go down through the baffle system, putting the energy into the wall of the boiler, because the boiler is separated by two 4mm skins. Flowing through those 4mm skins is your water flow to your central heating system. As it flows through, because it's being pumped, the energy from the burner that's being fired is actually going down a set of 4 baffles. Baffles are designed like this. The flue gases can go across those cutouts in the baffle system, which means that none of the heat, and we're talking about 1400 to 1500 degrees C in this area, should be imparted on the top of the baffle. It should be flowing down the sides and the back due to the cutouts. As it starts to go down the baffle system, it gets cooler and cooler because there's a lot less energy being applied to the walls of the boiler. And as the energy is being applied into the walls of the boiler, the water is heating up. As the water heats up, it's a standard physical property that as water starts to heat up, it will expand. But we don't want the skin of the boiler to expand. That's why we give you a 12-litre expansion vessel for the boiler. Any other expansion has to be calculated for the system. We also put a series of tie bars in to separate the 4mm skins and to act as a bit of a compressor for any expansion that does happen. As the energy goes down into the skin of the boiler, we're reducing the temperature. When we get to baffle 4, we've gone from 1500 degrees C right down to 250, about that area. There's still so much energy left that we want to use from that 250 degrees C. This stage, we turn direction and the flue gases go into this chamber here. This is the secondary heat exchanger. This is where the condensing is going to take place. The flue gases go across a set of these little baffles, and as they do, there's a set of tubes inside. The energy is put into the tubes, and this is the bit, this is where the energy efficiency comes in. The water that's coming from your central heating system is flowing across the tubes, so it picks up more energy. In fact, by the time you get to the back, the flue gases have travelled across the tubes. By the time it gets to here, they're down to 60 to 70 degrees C. So we've actually robbed quite a bit of energy because we've put it into the water that's coming back to the boiler. From then on, the flue gases have to change direction again. They go up this channel here and out to atmosphere through the flue system. So it's on a simple basis, but the product is condensate. When we turn the direction of the flue gases through the tubes, we take it down to its dew point. The dew point is acidic. It's 0.4, it's 4 pH about 4. So it's acidic. Right at the front of the boiler, all that water drains to the front. We then discharge it through our trap system. Safely disposed of. If you can remember, I said that the acid water will eat mild steel. So we can't have it come in contact with this chamber. It's definitely going to come in contact with this chamber. And in that fact, that's why we make it out of 316 stainless steel, because it's resistant to acid. So the process is simple. Fire in your flue gases, impart your energy in your water, all the way down, turn direction, pinch some more energy, and away to atmosphere. And that's the basics and the principle of condenser boiler. That's what is behind all that technology. So you can see this is where my team work very hard to make sure we get the most out of basically what is stainless steel and mild steel. There's the boiler in its finished entirety. You can see the one on the left is the standard efficiency boiler, but the one on the right is the principle that I've just been gone through, which is the condenser boiler. And there's the external model. Talking about the drop-down box, drop-down lights, we've been through that. These are the unique features: concealed access controls, front serviceable, that has to be important, multi-directional flue options, and a side panel for easy access. I didn't bring the flue down, did I?
Here's one we made earlier. Sorry.
Now, one of the things I found when I was in New Zealand was we used to supply you a low-level balanced flue, but the problem being was it's 450mm long. So if you put that into a traditional New Zealand house, it used to stick out miles, so you couldn't put the basket on it. Basically, we thought it's due to the construction of the house. We'll go back. We'll ask the flue manufacturers to actually construct ones for your properties. In my world, we have cavity. We go through a brick wall, we have a cavity, we have another set of brick walls. So that's why we had 450. This has been designed specifically for the New Zealand market. Remember, it's multi-directional, so you can put it on through that way, or that way. So it doesn't matter what direction you're putting it in, you've got many options that you can use. That's just going through the plug and play, the 12-litre expansion vessel, which I've been through on the model itself. And that's basically telling you, this slide is about the two separate heat exchangers, which we work later on, and about the trap itself. Remember, it has to be plastic discharging from that trap. We'll have all sorts of problems if we don't. As few bends as possible, and try and give it a 1 in 100 drop, so it actually drains away. The biggest problem with condensate is it is water at the end of the day. It will freeze, so make sure that when you do discharge it, you discharge it safely and you give it a full, because if that starts to freeze in the pipe, we will not be able to get this condensing process going, and eventually the boiler will start to give you problems. So it is important that that doesn't freeze in the winter. We've got one sparky in the room. I'm not going to labour on this. It's just to let you know that that boiler there needs a permanent light, because the burner that we've got supplied with it has got an overrun now, which you may not be aware of, but it's got a 15 to 20 second overrun to clear any gases that may be in here after the firing process is stopped. Fuel lights. Now, Mario and myself on the tables tonight have said that the fuel pump that is being supplied with that burner is 2-pipe. We'll even give you the 2 pipes. This has disappeared. We'll give you a 2-pipe pack with the boiler pack. The pump itself has been converted to 2 pipes for you. The reason is because Elco have recommended that you need a cooling effect on that pump, being diesel. In my world, we use kerosene. We don't need it so much. But for diesel pumps, we've set it up as a 2-pipe system. Now that may cause you aggro if you've only got a single pipe from your fuel tank. In the pack, we give you a T-piece. The T-piece is there so that you can put your 2 pipes into the T-piece and lead your single pipe from your tank into the remaining port of the T-piece. In that way, the pipes will act as a heat sink. You'll cool the pump down and you'll also lubricate at the same time. But there's an alternative. You can always use your Tiger lube. We've been through the design of the flue, but remember, we have got a balanced flue option still, a maximum of 6 meters. We have got horizontal flue option, 3 meters max with a 3-degree fall, because you can imagine, if you've got flue gases still in here, they will condense in a cold flue. They will produce condensate. The condensate will fall back to the boiler, fall back down the flue transfer into the trap and away to discharge. So it must have a 3-degree fall. And please remember, if you're going to put a vertical flue in and you're going to put some bends, keep it to 445s or 290 degrees. The reason being is if we start having a flue with multiple bends, we start causing a back pressure in the boiler. Back pressure in the flue is not good for our boiler at all. And remember, if you're doing a flue kit, the maximum is 12 meters. So we've got many fluing options. The Elco burner, you've been through that with Mario tonight. Just to show you that they do fire every single burner, and I can prove that. I've been over to the factory many, many times, tried to catch them out, but it's impossible. Every burner they manufacture, they do fire on our boilers. Just about combustion technology, Mario's been through that. I don't want to labour on that, but I do like to show you this here. It's where they set it up in the factory at 20 degrees, but please, please commission it with an analyzer when you get it on site. There's various things that can happen. You can use a different flue system, you can be halfway up a mountain, etc., etc., and all these things add to a change in the combustion. So please, when you do commission one of these up, use your analyzer and use the chart accordingly. If you're going to commission it at the outdoor temperature, make sure you come across and the little graph is actually inside the burner cover. Make sure you have the right CO2. And to adjust, just use your Formula Allen key to slightly adjust it up or down. The plug and play approach, I'm not going to labour on that, we've been to death on that, but this is the typical boiler installation in Ireland. It's one of the first that we ever did, and this is going back now maybe 4 years. 4 years ago, it's had 4 services on it, and every time we've been to that boiler, it's as clean as the day we put it in. This is a picture of the burner head after 2,000 litres of fuel. As clean as it was when we first installed it. Now remember, I'm not going to tell you to suck eggs, all this is in the manual. It's commissioning it up for the first time. Make sure it's bled correctly, you've got no negative pressure on your pump, because that will cause you trouble. Monitor the combustion values after 15 minutes of running, put your analyzer in, do your fine checks. Periodic maintenance, this is basic stuff. Flame sensor, clean it. The nozzle, replace it. Always check the position of the electrodes. Always verify the pump pressure. The fuels have to be cleaned from the tank and the pump. And the flexible oil lines, check them to make sure they're not cracked. A fuel tank, remove the water. And combustion, finally with the combustion head, we give you this special tool that's connected, it's actually inside the burner cover. When you come to your periodic maintenance, please use it, because it's a simple 3 checks. It's to make sure you've got the right setting for that burner. It's very, very simple, and the guys that have been on the table tonight with me would probably say yes, it is. And then the servicing checks to make sure your electrode's the right gap. Thank you for your time. Are there any questions? Well, thank you very much. Nick?